All right, welcome to our little lesson on buck boost transformers. Today we are going to be diving in and talking about a device called the buck boost. It's a piece of transformer equipment that's designed to help you install equipment that doesn't have the right voltage for your facility. So I'm going to go through a typical example. Let's say I am a grinding machine company. I've sold you a very fancy grinder, but my grinder runs at 208 volts AC, and your power in your facility is at 240 volts AC. For this example, we're going to stick to single phase. So we assume the grinder needs single phase, and the power coming in is also single phase. If you remember, single phase 240, each wire is hot, but they're slightly off phase from each other. So the differential between this leg and this leg is 240 volts. But my grinder needs a differential of power going in of 208 volts. Generally speaking, you're allowed to have up to a 10% differential. So a 10% differential is okay. But here we can see that if we add 10% to 208 volts, we're only getting up to 230 or 228 approximately, 229 to be exact. And that's not enough. It's too low for my 240 volt. I may cause problems in my device. A lot of times buck boost transformers are installed for equipment that was wired wrong to begin with, slightly low or slightly high, and you're solving weird problems with fuses blowing and equipment not working right. By increasing or decreasing the voltage slightly, you're making that equipment more reliable to match exactly what you need in your building. Typically, also, many buildings have voltages that vary a little bit, especially in the summer when there's high demand. So what used to be 240 or 245 might drop to 230 or even lower. So something that would boost this 240 to say 250 means it's slightly high, but when it starts dropping in the summer, it doesn't drop so low that your 240 volt or your 230 volt equipment will be a problem. So a buck boost transformer handles all of those cases. The example we're going to use is a simple transformer for decreasing my voltage. The same exact transformer can also be used to increase voltage depending on how you wire it. So what we're going to do, number one, is we're going to go through the process of selecting a transformer, and then we're going to look at the wiring diagram in a transformer, typically for this application. So the first and the hardest part about selecting a transformer is choosing the size of the transformer. This machine right here uses a certain amount of power. And depending on the power it needs, I will upsize my transformer appropriately. So for examples of this particular lab I'm doing here, for example, I'm going to assume this needs 1,000 watts of power. So my power is equal to 1,000 watts. Transformers are sized based on what they call kVA, or thousands of volt amps, kVA. So voltage times the amperage, P equals IV. So amperage times voltage is the same thing as power. So a 1,000-watt single phase circuit is simply equal to 1 kVA, or 1,000 volt amps. Okay. If I had three-phase power, I would actually multiply this by the three-phase power factor, which is 1.73, I think. And so I would need to do that multiplication to give the size of the transformer. So my transformer would have to be slightly bigger. But since I'm using single-phase power, volt amps is equal to your watts, essentially. So I need to go find a 1 kVA transformer. And I need to find a good wiring diagram to show me how to use that 1 kVA transformer. So the examples I went to, and the other important factor is I want to reduce by 32 volts. right? So I need to have a 1 kVA transformer that can reduce one of my legs by 32 volts. Because that's what I'm doing here. I'm only going to grab one of these legs and reduce it. I'm using this transformer rules about coils against coils to suck some of the essential power out of one leg or into one leg to change one leg either higher or lower voltage. In this case, I'm doing lower voltage. So I want to reduce by 32 volts. So I need to pick the right transformer for that. So what I'm going to do is pause and let's go look into some transformers. All right, so I did a little search and I went to a website called Square D Schneider Electric. So let's go take a look at that website. In Square D Schneider Electric, with a Google search, it suggested this transformer and catalog, which gives me a range of different sizes and configurations. So I'm going to go click onto my download for my documentation, and let's click into this document. So this is a class 7414 buck boost transformer. So it can handle 120 or 240 with either a 12, 24 volt or 16, 32 volt secondary. And that 32 volt secondary is what I want here. I want to be able to drop my voltage by 32 volts. I also have the option of 240, 480 or 24, 48 secondary. I don't want that. I want this one right here. So let's go pick the right transformer for that application. And we also specify in this primary table, this is the primary table that's right at the beginning of this. It shows you the kVA on the left. It shows you the part number if I'm going to go 12 or 24 volt secondary. And here's the part number that I want, which is the part number for the 16 or 32 volt secondary. So that 1S46F part number will give me what I want in terms of a 32 volt secondary. So I've got my part number right there, straight from Schneider Electric's transformers. Other manufacturers have other ranges. I like 32 volts for this application. Not all manufacturers provide you a secondary at 32 volts. So let's figure out how to wire this up. Let's go down a little further. And we're going to go to the selection table. And we're going to look at table 5 on page 12, which gives me my required load of 208. And if I go to page 5, I see my part number down here, but it also gives me, is this page 12? Oh, that's not page 12. I got to go down to my page 12, 10, 11, 12. And there's my part number I selected, right? And we are going to be using diagram 4 to give me my voltage that I want. So let's go back up to wiring diagram 4. And there's my wiring diagram 4. It's basically showing me how I can have a high voltage side and a low voltage side. So let's zoom in on diagram 4. And let's steal the diagram out of this document using my snipping tool. And I'm just going to grab that diagram out of the document. And let's talk about how we're going to wire this up. This diagram shows me the different terminals inside the transformer, H1, H2, H3, and H4, as well as X1, X2, X3, and X4. Typical buck boost transformers don't have these as points like little screw terminals. They drop them out of the transformer as pigtails. So these will be individual wires dropping out of the bottom of the transformer that are clearly labeled with the H1, H2, etc. wiring diagram, and I will link you to a video showing somebody wiring this. All right, so in order to get my output voltage of 208 with an input voltage of 240, what I need to do then is wire in my output, I'm sorry, my input here. So this is leg 1 in, okay, being attached to that point, and then my leg 2 in is being attached to that point. So what I'd be doing essentially is giving my high voltage in, I'll take my low voltage out. So my leg 1 out would be attached to that point, and my leg 2 out would be attached to that point. So that gives me my output voltage of 208. In other words, drop it by 32 volts. But then from a wiring perspective, I just basically I'm going to take a wire nut and I'm going to attach H1 to L1 out and L1 in. So all three of these are going to be wire nutted together, 3 wires wire nutted together. The other thing I'm going to do is I'm going to have L2 in attached to X4. So that's going to be wire nutted together, just 2 wires. And I'm going to take H4 and X1 and attach that to L2 out. So those are 3 wires wire nutted together. And those are my inputs and my outputs to the transformer. But because this is a flexible use transformer, I also need to wire nut together X2 and X3, and also wire nut together H2 and H3. By wiring nutting those little jumpers together, it creates the circuit that gives me that full 32 volt power, or I'm sorry, 32 volt voltage reduction. So this is how I would select and also wire up a, in this case, a buck or voltage reducing transformer. One final note is sometimes single phase power and even 3-phase power as well, you'll take one leg and then that one leg would be used against neutral or ground to give you 120 volts. So in this circuit, I have to be very careful that I don't try to use my leg 2 as a source for 120 volt circuit, because it won't be. It'll be more like 90 volts. So that won't be good. So I have to make sure that if my machine over here on the right uses one of its legs for a 120 volt circuit, that the L1 is the one that I use. I don't use the leg that I've reduced. So that's pretty much what I want to do here. If I'm going to show this diagram on my little chart, it's going to look like this. I've got one coil, a second coil, and 2 little coils. Okay, and so I'm going to take my wires and I'm going to attach it to the bottom, the high voltage side there, and I'm going to hook them to, in this case, it's H1, and this is going to be X4, right? And then I'm going to take my input side, and let's say I've run one of the wires over to the high. So the leg in is also associated with the leg out, also L1, to my machine. And then my other wire to my machine, I'm going to hook to this point right here, which is attached to H4 and X1. And then I'm going to jumper X2 and X3, and I'm going to jumper H2 and H3. When I say jumper, I mean you just wire nut them together. You're going to wire nut those leads together. You're going to wire nut these leads together. You're going to wire nut the output on L2 to H4 and X1, and you're going to wire the input on L2 to X4. So you're just going to wire nut those 2 together. So that way you've got your power equivalent going in and out, but you're doing a voltage reduction on the output side.